So we talked about linear equalities. Now we're going to talk about linear inequalities, specifically solving linear inequalities in one variable. The big difference here is this word inequality versus equality, okay? So when we're dealing with equalities, we have the equal sign. When we're dealing with inequalities, we're talking about these signs here, okay? The less than, greater than, less than and equal to, and greater than and equal to signs, okay? These give us a relationship between our variable and a number. So for example, if I have something like x is less than 3, this means all numbers smaller than 3. And we saw at the very first section how we can write this, x is less than 3, in interval notation. In particular, we first showed this on a number line. X is less than 3, so if this is 0 and this is 3, x less than 3 would be everything to the left of 3, and we would write that as negative infinity to 3, and we'd use the parenthesis with the 3 because 3 is not included, okay? Similarly, if we had something like y is bigger than or equal to 4, we could show this on a number line. If I have 0 here and 4 somewhere over here, y bigger than or equal to 4 is going to be everything to the right of 4. And since we're bigger than or equal to, we fill in that circle, showing that 4 is included. As an interval, this would be 4 to infinity. We're using a bracket because 4 is included. Remember, we always use parentheses with negative infinity to infinity, and we always work from left to right. So we start on the left and work our way to the right, okay? Greater than and less than or equal to work similarly. So what we want to do is we want to take statements or inequalities, reduce them, so we have our variable less than or equal to, greater than or equal to, less than or greater than a number, and then write the solution in terms of an interval, okay? So the good news is, in a lot of ways, solving linear inequalities is very similar to solving linear equations, meaning we're going to think about doing the same thing on both sides of our inequality symbol. We're going to come down to a solution. We can end up with contradictions, identities, and conditionals. But there are two, or one, depending on how you think of it, main difference here, okay? So let's look at a linear inequality. If I have something like 3 plus x is greater than or equal to 4, and I want to solve this, okay? Well, when I'm adding or subtracting, nothing really changes. So for example, if I wanted to solve this, I would subtract 3 from both sides. Okay, 3 minus 3 cancels, and I would be left with x is bigger than or equal to 4 minus 3, which is 1. So here's my solution. X is bigger than or equal to 1. I would want to write that as an interval. Now, if you need help, go to the number line. Let's see if we can do that without the number line. X is bigger than 1. So we're going to start at 1 and do everything bigger. So that's 1 to infinity. We never include infinity, so it's a parenthesis. Since we're bigger than or equal to, that means 1 is included. So here would be our solution, okay? If we're adding or subtracting on either side of the inequality, nothing really changes. What do I mean by that? Well, a nice way of sort of showing what I mean by that is just using numbers. I'm going to write a statement that's true. 2 is less than 3. This is a true statement because, hey, 2 is less than 3. Notice if I add, so let's say I add 5 to both sides here. 2 plus 5 is 7. 3 plus 5 is 8. Well, guess what? 7 is still less than 8. Adding doesn't do anything to our inequality. The same is true for subtraction. Now, where things get interesting is with multiplication and division, particularly when we multiply or divide by a negative, okay? So let's again start with a true statement. 2 is less than 3. And let's look at what happens when I multiply both sides by negative 2. So multiplying by negative 2. Sorry, I don't like the way that notation looks. We'll multiply both sides by negative 2. Negative 2 times 2 is negative 4. 3 times negative 2 is negative 6. Now look at those two numbers, negative 4 and negative 6. Which is bigger? Well, negative 4 is actually bigger than negative 6. So that means in order to preserve truth, to make the statement true, the direction of my inequality needed to switch, okay? That's true when we multiply by a negative. It's also true when we divide by a negative. Now, we don't need to switch the direction of the inequality when we just multiply by a positive number. So, for example, 2 is less than 3. That's our true statement, okay? If I multiply both sides of this by, say, 4, just a positive number, 4 times 2 is 8. 3 times 4 is 12. Well, 8 is less than 12, so the direction of my inequality stays the same, okay? So the important thing to remember, anytime we multiply or divide by a negative number, not a positive number, a negative number, in order to preserve the truth with our inequality, the direction of the inequality needs to flip, okay? And why is that? Well, that has to do with sort of position from 0, right? If I look at 2 being less than 3, where we started with here, okay? Well, being less than, right? If this is 0 and this is 2 and this is 3, being less than means you're closer to 0, right? So 2 is certainly closer to 0. Now, when we multiplied by -2, what multiplying by a negative does is it switches where we are in relation to 0. Here we're on the right side, we're going to go to the left side, and then we have 4, right? Then we had -6 and -4, right? So now -4 is closer to 0 than -6, okay? So has to do with relative position to 0, but the big idea is anytime we multiply or divide by a negative, the direction of our inequality has to switch. Let's look at that with a couple examples, okay? All right, so I'm gonna write up an example here. Okay, -3x plus 9 is less than or equal to 12. So to start with, we're going to go about solving this really similar to the way we would solve an equation. I'm going to subtract 9 from both sides to get all my terms with x on one side and all my terms without on the other. This leaves me with 3x, 9 and -9 cancel, less than or equal to 12 minus 9 is 3. Okay? Now here, notice, to get x by itself, I need to divide both sides by -3. Little warning bell should be going off in your head. Ding, 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 ding. We're dividing by a negative. That means we have to switch the direction of the inequality. -3 over -3, that cancels, so I'll have x. I'm going to switch the direction of my inequality. Instead of less than or equal to, this becomes greater than or equal to. 3 divided by -3 is -1. So here's my answer. X is bigger than or equal to -1. In interval notation, that says I'm going to start at -1 and take everything bigger, so -1 to infinity. Never include infinity, or bigger than or equal to, so I need to include that -1. Okay. Now, just kind of to help drive home the point, let's say we forgot to switch the direction of the inequality. So we left this as x is less than or equal to -1. Well, what's a possible solution here? What number might satisfy x is less than or equal to -1? Well, x could be -2, right? -2 is less than or equal to -1. But if we plug -2 in up here, -3 times -2 plus 9, well, -3 times -2 is 6. 6 plus 9 is 15. But is 15 less than or equal to 12? No. So if we forgot to switch the direction of that inequality, we got an answer that wasn't true. That's not good. Let's just check. Let's just do a test answer in here and make sure it works. What's a number that's bigger than -1? Well, there's lots of them, right? Infinitely many of them. That's why we write our answer as an interval. But 1 is a possible answer. X equals 1 would be a possible answer because 1 is bigger than or equal to -1. What happens if we plug in 1 here? Well, I would have -3 times 1 plus 9. That's what I have on the left-hand side here. -3 times 1 is -3. -3, plus 9 is 6. Is 6 less than or equal to 12? Yes. Okay. So notice that by switching the inequality, we get a correct interval. Okay, let's look at a couple more examples. Okay, here's a couple more examples for us to look at. So first we have 3x plus 2 times x minus 7 greater than or equal to 4x plus 12. Okay, all right. So let's see what we would do first. First we would distribute. So I'll have 3x plus 2 times x is 2x. 2 times negative 7 is negative 14. Greater than or equal to 4x plus 12. Now let's collect like terms. 3x plus 2x is 5x. Minus 14 is greater than or equal to 4x plus 12. Now I want to get all of my x's on one side. I'm going to subtract 4x from both sides. 5x minus 4x is just x. Minus 14, bigger than or equal to 4x minus 4x cancels. Equals, or sorry, it's bigger than or equal to 12. I'm going to add 14 to both sides. So I'm left with x is bigger than or equal to 26. Now notice here I didn't have to worry about flipping the sign because I never divided or multiplied by a negative number. Okay? So here's my answer. X is bigger than or equal to 26. I want to write that as an interval. Well, x is everything from 26 bigger. So I'm going to start at 26 and go to infinity. And never include infinity. I am going to include 26 because I'm bigger than or equal to. So there's my answer. All right. On the other side there, we have 0.6y minus 2 times 0.5y plus 0.2 is less than 0.6 minus 0.3y. All right, decimals in there. We're not going to worry about them. We're just going to work with them. First thing we're going to do is distribute. So I'll have 0.6y, negative 2 times 0.5. Negative 2 times a half is negative 1, so negative 1y. Negative 2 times 0.2 is negative 0.4. Is less than 0.6 minus 0.3y. Okay, let's collect like terms. I've got 0.6y minus y. Okay, here's a little hint or a little trick. You can work with these decimals. That's perfectly fine. You have a calculator, you can use your calculator. However, if you don't want to work with the decimals, multiply everything in this problem by 10. In other words, multiply both sides of this inequality by 10. I'm multiplying by a positive number. I don't need to switch directions. Okay? When I do that, look at what happens. 10 times 0.6y becomes just 6y. 10 times negative y is negative 10y. 10 times negative 0.4y is negative 4. Sorry, there's no y there. Just negative 4. Less than 0.6 times 10 is 6. Negative 0.3y times 10 is negative 3y. We've cleared the decimals just like we cleared the fractions before. Okay? Now, 6y minus 10y is negative 4y. Minus 4 is less than 6 minus 3y. I want to get all my y's on one side. I'm going to add 3y to both sides. I'm going to do two steps at once here. I want to get my y's over here, but I also want to get my terms without y over there. So at the same time as adding 3y to both sides, I'm also going to add 4 to both sides. If you don't like doing those two steps at the same time, that's fine. You can do them separately like we did over here. Negative 4y plus 3y is with negative y. Negative 4 and positive 4 cancel. 6 plus 4 is 10. Negative 3y plus 3y cancels. So I'm left with negative y is less than 10. Dividing both sides by a negative 1 to get rid of this negative gives me y. I'm dividing by a negative. What do I have to do? That's right, I have to flip the sign. So less than becomes greater than. So I have y is greater than 10 divided by negative 10 is negative 10. Okay. So I want all things bigger than negative 10. I'm going to start at negative 10 and go to infinity. I never include infinity. In this case, I'm strictly bigger than negative 10, so I'm not going to include negative 10 either. Okay? All right, so there's two examples of solving inequalities. I'm going to put up 3 more examples. All right, 3 more examples. Okay, so let's start here. 1/5 x minus 1/7 x is bigger than or equal to 2. All right, so the first thing I would do here is I would clear my fractions. I would look at my denominators, 5 and 7, and look for the LCD, or the least common denominator. In this case, the least common denominator of 5 and 7 is 35. So I'm going to multiply both sides of my inequality by 35. Okay? I'm multiplying by a positive number. I don't need to worry about switching the direction of my sign. But what's the advantage to that? Well, when I do 35 times 1/5 x, 35 and 1/5 cancel, just leaving me with 7x. When I do 35 times 1/7 x, 35 over 7 cancels to just leave me with 5x. That's going to be bigger than or equal to 2 times 35, which is 70. Now notice that I just cleared the fractions there, which makes, I think, this a little bit easier to work with. So now 7x minus 5x is 2x. 2x is less than or equal to 70. Dividing both sides by 2 gives me x is less than or equal to 70 divided by 2 is 35. So x is bigger than or equal to 35. To write that as an interval, I start at 35 and I go to infinity. Never include infinity. Greater than or equal to, so I'm going to include 35. Okay? All right. Excuse me. Let's look at our next one here. So our next one, we're going to start by distributing. So I'm going to just, well, let's distribute and collect like terms. On this side, I'm going to collect like terms. 7x minus x is 6x plus 4. Bigger than, I'm going to distribute here. 2 times 5 is 10. 2 times 3x is 6x minus 8. Now I'm going to collect like terms. 6x plus 4 is bigger than 10 minus 8 is 2. So 2 plus 6x. Maybe you're noticing something here. In general, we would then try and get our x's on one side. So I'd subtract 6x. 6x minus 6x cancels, leaving me with 4 is bigger than 6x and negative 6x cancels. So I'm left with this statement. 4 is bigger than 2. Okay, think back to what we did with equalities. When we did equalities, we had contradictions, identities, and conditionals. We're going to have the same thing here. Okay? So what happened when our variables fell out or canceled out and we were left with something that didn't have variables? Well, either what we were left with was true, meaning we had an identity, or what we were left with was false, meaning we had a contradiction. Is this true or false? 4 is bigger than 2. Well, that's true. That's a true statement. 4 is, in fact, bigger than 2. So this is a true statement, meaning this is an identity, meaning everything works, okay? So all real numbers are a solution. How do we write all real numbers in interval notation? We say negative infinity to infinity. So this is an example of an inequality that is an identity. All of our variables fell out and we were left with something that was true. All right, let's look at this last example here. I'm going to distribute. Negative 2 times 7x is negative 14x. Negative 2 times 4 is negative 8. Less than or equal to. Negative 7 times 2x is negative 14x. Negative 7 times positive 8 is negative 56. Okay. I notice I've got negative 14x on both sides. What do we think is going to happen? Well, if I add 14x to both sides, my 14x's cancel, and I'm left with negative 8 is less than or equal to negative 56. So we're again in the case where our variables fell out, no more variables, and let's look at what we're left with. Negative 8 is less than or equal to negative 56. Well, that's a false statement, right? Negative 8 is not less than 56. It's certainly not equal to 56. So this is false. What happens when our variables fall out and we get a false statement? Well, this is a contradiction. Okay. When we have a contradiction, there are no solutions. Okay? Or you can say the solution is the empty set. Okay? So an identity and a contradiction in inequalities, just like before, our variables fall out and we either get something true, identity, or something false, contradiction. Now, just like with equalities, when we get one solution, something like this, we do usually call this a conditional, same name, conditional. Meaning this is conditionally true as long as x is between 35 and infinity and not true otherwise. Okay? So just like with equalities, for inequalities we can get conditionals, identities, and contradictions.